5.1 is graphing linear inequalities. So we're going to piggyback on what we did last module, where we graphed lines. So that's the first statement that's here. It says, similar to a linear equation, a linear inequality is the same thing but uses an inequality symbol. And the solution to a linear inequality is all of the ordered pairs that make it true. So the first couple examples we are going to solve algebraically, and then we'll get into the graphing below. So it says determine if these 4 ordered pairs are solutions to the inequality that is given. So in order to figure that out, we know our ordered pairs have an x and a y value. And within our inequality, we also have an x and a y value. So we're going to substitute those values, and then we're going to evaluate. So we're going to have 2 times the x value of 2, subtract 3 times 5, and we're going to see if that answer is less than 15. Okay, we know 2 times 2 is 4, 3 times 5 is 15, and 4 subtract 15 we know is negative 11, and negative 11 is less than 15, so yes, 2, 5 would be a solution. I'm going to zoom in a little bit. We do the same thing for the second one. It's just going to be a plug and chug to see if it's true or not. So I plug my x value and my y value in for my correct variables. I multiply first because I'm following order of operations. Negative 2 plus 21 is 19. And we know that 19 is not less than 15, it's larger. So no, this ordered pair would not be a solution. Last one we'll do together. Again, you're plugging in the x and the y values into the inequality. Multiplying first to follow order of operations, and we'd get a positive 12 because of the 2 negatives. And 6 plus 12 is 18, and 18 is not less than 15. So now you guys need to go ahead and do this one. So I'd pause the video and do that. Now we're going to start graphing. So the first step, just like it was when we did equations, is we need to write the inequality in slope-intercept form. Then this is an important note that we kind of forgot about when we did it in module, I think 2. Be sure to flip the inequality symbol if you multiply or divide by a negative. So I'll show you lots of examples of that. Step 2, we are going to steer away from doing open and closed circles, and now we're going to use dotted versus solid lines. So we're going to use a solid line when we have less than or equal to or greater than or equal to. We're going to use a dotted or dash line if it's less than or greater than. So if you recall from module 2, the solid line is your closed circles and your dotted was our open circles. We're also going to shade just like we did on our number line, but now we're going to be shading an entire portion of a coordinate plane. So you shade above our line if it's greater than or equal to, and we're going to shade below the line if it's less than or equal to. And so step 2 and step 3 you guys need to have memorized by our first quiz later on. So first example is going to follow all 3 steps. So step 1 says be sure to put the inequality in slope-intercept form. So remember, we're going to solve for y, which means we're going to bring the x over to the other side. The 2x's cancel, and we have negative 3y is less than. We need to write our x value first, followed by the 15. And our last step is to divide every number by a -3, so our y is isolated. Okay, now I just divided by a negative number, so we need to flip our inequality sign the other direction. -2 over -3 turns positive, and 15 divided by -3 turns to -5. Okay, so my inequality sign is greater than. So if it's greater than, I'm going to be shading above, and I'll have a dotted line because of this symbol right here. So I'm going to go to my graph. I find -5 at the bottom. I go up 2 over 3, and I can only fit that in once, so I guess that's all I'm going to do. Again, it's dotted or dashed, so it's not your solid line. And you shade above it, so it's an entire region now, and this entire area is technically your answer. Moving on. Number 1. This is already in slope-intercept form, so we don't need to change it. So we're just going to determine, is it going to be dotted or solid, or dotted or solid, and where are we going to shade? So I'm looking at my inequality sign, which is right here. It's greater than, so it's going to be above, and it doesn't have the equal to line under it, so again it's going to be dotted. So I start at -5. My slope is 1/3, so I'm going up 1 over 3. Already established it's a dotted or dashed line. And again, shaded above. So this lesson is good with highlighters or colored pencils. Number 3, we need to get into slope-intercept form because currently it's in standard form. So that means we're going to solve it for y before we can do anything. So I need to zoom in. So I'm trying to isolate the y variable. So I'm going to subtract 5x first. Rewrite your -5x first. Divide everything by a -2. I just divided by a negative, so my inequality sign needs to turn around the other direction. 5 over 2 negative is going to turn positive, and 12 and -2 we know is -6. So based off of my inequality sign, which is now less than, I'm going to have a dotted line, and it's going to be below because of the, there's no equal to line. So we find -6 on the y and climb up 5 to the right 2. And so I said dotted. So I just made a little bit of a mistake. So if you've noticed, I'm drawing my lines all the way through the coordinate plane because we're coloring entire regions of a graph. So my answer is the entire region below it. So I have to color all parts below the line, not just a little circle or not just a little area. Five, same thing. Standard form needs to shift into slope-intercept, so I'm going to solve this 4y. So, as always, you get rid of your x value first. Cannot have a negative y, so we divide everything by a negative 1. I just divided by a negative, so I need to flip my inequality sign the other direction. Negative x over negative 1 turns positive, and your 8 is going to turn negative. So now I finally have an equal to line. So this is going to give me a solid, and it's less than or equal to, so I'm going to color below my line. So I'm starting all the way down at negative 8. Recall that the slope, if it's x, it's really 1 over 1. So I'm going up 1 over 1. And there's my 3 points, but again, draw your line all the way through, and I'm shading below it. Number 6, I want to make sure I do a 1 with 0, because I know that's something that is sometimes problematic. In standard form, we need to shift into slope-intercept. So we start by getting rid of our x value. We do not need to write the plus 0, that's just a placeholder, but I'll keep writing it. Divide by 2 to get the y alone. The 2 happens to be positive, so I do not need to turn my inequality sign around. However, my slope is negative, and we know that 0 divided by 2 is just 0. So again, you don't have to write the 0, but you can. That's telling us to start at 0, 0. And our slope is negative, so we're proceeding down 3 to the right 2. Down 3 to the right 2. My inequality sign is less than, so it's another dotted or dashed line. And that means it's going to go underneath, because again, it's less than. So, dotted dashed line. Color underneath it, which is going to be to the left. Like the left/under. Okay, last 2 really quickly before I run out of time. So we have another y, and then inequality sign negative 4. So if this was a y equals, remember y equals side to side. So I find negative 4 on my y, and we're going to go side to side. But first I need to look at my symbol. It's less than or equal to, so it's going to be solid. And it's less than or equal to, so it's going to be below, whoops, that was crazy, below or under it. If it's an x value, remember x is low to high, so I find 7. If it's greater than, it's going to be above, but in this case, all the numbers greater than 7 are to the right, and again, this is dotted. So my dotted line, all the numbers on x are greater than 7, so that means I'm going to like 8, 9, 10, 11, 12. So I'm looking at that as like more of a number line kind of scenario. Okay, that is your notes. You guys have to go in and you need to finish before I check your notes tomorrow. The one on the front and 2 and 4. So do the 3 problems that say you.